All right, so what we're going to do in this video is figure out how to work with paginated APIs, which is an API where it doesn't give you all of the information you want at the same time, and maybe you have to make a few different requests and combine them in order to get the total number of results you're looking for. The API we're going to be using is this Pokemon API here, and the way we're going to be using it is we're just going to be grabbing a list of every single Pokemon that exists. So this is the URL that we're using. Gives you a ton of Pokemon, very exciting: Bulbasaur, Ivysaur, Venusaur, etc., etc., etc. What we're going to do is we are going to figure out how to get all of the Pokemon in at least 4 different ways, because when we start dealing with this API, there's an issue. Let's see it happen. This is the URL that I just showed you. We're grabbing 100 Pokemon at a time. We're just using basic requests, blah, blah, blah. If we look at data, the very first thing we're going to zero in on is these results here, because we love Pokemon. We just want to see lists of Pokemon. So exciting. All these Pokemon. So many. We can just jump right into those results and look at them. They're a list. How many Pokemon do we have here? 100 Pokemon. But there are more than 100 Pokemon. So what's happening here? Well, if we look at how this is set up, we see the very first part of this result from the API says 1118 for the count. And if we read the documentation, which hopefully we did, but maybe we didn't, we might realize that, oh, there are actually 1,118 different Pokemon. So we will have to get them 100 at a time, again and again and again, until we have caught all of them. Now, the way that we do this, we see a hint here. The next URL is offset equals 100, limit equals 100. Let's take this URL and look at what happens when we request it. So I'm just going to throw it on in here, and then I'm going to look at data. Now it looks pretty much the same, except if we look at the results, we see that this one starts with the Pokemon Electrode, Pokemon 101, and if we go to our last request, we see that it started with Pokemon 1, Bulbasaur, and then Pokemon 2, etc., etc. So what's happening with this URL is it's giving us 100 at a time, but when you make the request, along with saying, I only want 100 at a time, you can also say, let's skip the first 100, or, as you're seeing right here, the next page is skipping the first 200. So skipping the first 200, we're now down to this Pokemon here, Pokemon 201. And if we keep going all the way up to something that's around this count, we'll see if we can't get to a point where we have our final Pokemon. Okay, so if we get to 1100, we are here and we see results is not nearly as long of a list. If we went up to 1200, we would now see that we have no more results. So pretty much what we need to do is we need to start from the page of limit equals 100, which we could also say is offset 0, limit 100, and then go all the way up to this, collecting Pokemon as we go. Now, is this the best way to do it? No. What we're going to do right now is we're just going to make a loop where we step through the offset like this. There are a few different ways to do this. What I would probably do is we're going to start off with a limit of 100 and an offset of 0, and then I'm just going to loop. So how many pages of content are going to be in here? For I in, what is it going to be? 12? We'll see. So we'll say limit is, and print offset is, And every single time we go through here, we're going to increase offset. Or there are a few different ways to do this. One way could be we're just going to add 100 to offset every single time. I'm going to add a line here. Maybe I'll even, yeah. So offset just increases by 100, 0, 100, 200, 300, and then it goes up to 1100. Another way to do this is kind of our page number right here. So I could say page number times 100. And then because page number is 0, 1, 2, 3, 4, what range does is it basically counts up 0, 1, 2, 3, 4, all the way to 11 in this case. Uh-oh. Oh, because it starts off as 0, I need to move the print down here. So yeah, I guess it depends on whether we want to add at the beginning or the end. The way that I'm going to do it is I'm going to work with this page number thing, because usually speaking, when you have an API, sometimes you get to say the offset, and sometimes it's going to be like page number 1, page number 2, page number 3, and on the other side it's going to automatically calculate the offset for you. So we're going to stick like this. We're going to say our limit is 100. Every single time we go through, we're going to calculate the offset. We could also change this to be page number times limit, probably the fanciest way to do it at the moment. And what this will do is if we change the limit, then it will end up changing the way that it steps through the offset. So let's build a URL. I'm going to steal this URL here. I'm going to say URL equals blah. Fill in the blanks. Offset is this. Limit is that. And then I'm going to print out the URL. F strings, sorry. So there we go, takes us up to 1100. Now what we need to do is we need to, as we go along, collect all of these Pokemon into a single list. The way we're going to do that is something called extend. So if I have a list of things, and it is 1, 2, 3, 4, 5, and then I have more things, and that is, you know, some other numbers. If I want to combine these two lists, the way that I will combine these two lists is by something called extend. And what extend is going to do is it's kind of a way of adding multiple elements to one list. So if you have two different lists and you want to combine them, you can use extend. And so now magically more things has been added onto list of things. All these things here are all these things here, and they just got thrown over. So nothing too crazy. Just what we're going to do is every single time we go through, we're just going to add onto our list of Pokemon. And as we saw before, Pokemon, they live in data results. So in the very beginning, I'm going to say I have no Pokemon. And then every single time I step through and I get this URL, I'm going to say, hey, go get that URL, process the JSON, and then add the Pokemon onto my list of Pokemon. Before I make the request, I'm going to print out that I am making the request here. It'll just make things a little bit easier, because if there's something goes wrong with the processing, at least I'll know where it went wrong. So I'm going to run this, requesting. And now if we look at the number of Pokemon I have, it's a lot. We can look at the actual Pokemon themselves. It goes from Bulbasaur all the way down to even more than that. So I guess I can look at the last one. The last one is Toxtricity Low-Key G-Max. All right, that's much more complicated sounding than Bulbasaur. Okay, so that was the first way to do that. This is probably the worst way to do it. You don't often know, so pros. maybe easy to think about. The cons of doing this method, which we'll call the discrete paginated method, we'll call it the, we know how many pages we have method. The cons are you need to know how many pages it is. So it's not very flexible. Okay, the next method we will use is listening to the API. So when we made a request to the API, we'll grab this from the very, very top. One of the things that it gives us is this next URL here. And it turns out that we can just keep grabbing that next URL until there is no more next URL. So let's say this is the very first request that we make. And it says, okay, this is the next URL. And I say, okay. I grab this URL and I put it in there. And it says, okay, now this is the next URL. And I say, okay, I'm going to do it. And I say, oh, wait. Instead of just copying and pasting this in, I could just use data next, right? I could just paste that right there. And so this says, all right, it's, gets the next URL, and then it processes that URL, and here's our new next URL. And then we're going to take this new next URL, grab that, and then get the next URL, and it's just going to keep going. So we can just keep running this code, until eventually there's no more next URL. All right, so we start by saying, hey, here's the URL that we should request. We add in, this is our manual work this time. We're saying this is the URL we're interested in. And then we just keep running this code until there's no more next URL in the request. Now, if you want to run some piece of code until something is true or until something is false, you're going to be using a while loop. And so here's what we're going to do. We're going to store this URL. Maybe we're going to call it next URL. And we're going to say, hey, while there is a next URL, do this stuff. So what's going to happen is I'm going to say, hey, here's the URL that I'm going to hit. If it exists, then grab, go to the, change that to next URL. I should have clearly just kept this as URL for cut and paste sake, if nothing else. So what we're going to do is we're going to say, hey, this is the URL we're starting at. Grab it, get the information, and if there is a next URL, save it to the variable URL. And then that is going to go back up here to the beginning of this loop. And as long as it finds a next URL, it's going to keep running this code. So as we always do, let's say requesting URL, and it's just going to print it out. So it keeps grabbing, and then magically, without us having to know how many pages it is, it finally runs out there because there is no URL at here. We can look at that again. If we look here, we see next is actually missing data, whereas for the very first page, there is a next URL. So it just keeps going until there is no more next page that's being pointed at. If we want to make this actually work, and if we want to make this actually grab the Pokemon, we can do the same thing we did before, where we start with an empty list of Pokemon, and every time we use .extend in order to add to it. So I'm going to say Pokemon is nothing, and while I'm doing this, I say Pokemon, please be extended by the data here. There's no real reason to do it in this order. It just seems to make sense to grab the new Pokemon and then just, whenever we're done, update the URL. All right, so we're going to try this again. Run. And then I can look at the number of Pokemon, and I again have that nice big number. One thing to notice is that if we've listened to what the API says, for the very last request, it says limit 18. Whereas for the very last request last time, because we were always saying limit 100, it is limit 100, even though it's the same offset. Is there a difference between those? No. It just knows there are only 18 left whenever you hit 1100, so the API is smart enough to say, oh, you only want a limit of 18 here. All right, so next up, there are two more. So going until there are no more results and going until there's an error. Let's see, let's pros and cons of this one. So this is the method of listening to the API. And the pros are the API knows what's going on inside. And it's good if you don't know how many pages there are. Pages or results, shall we say. The cons are the API has to actually tell you the next page. It's not always the case that you get information about what the next page is. And so that's what we're going to do for this next one, which is going until there are no more results. So if we go back to this right here, actually, let's go back to, we'll start from this URL because it's near the end. So if we grab this URL, and then we get all of the Pokemon. There are a lot of Pokemon here, right? Billions of Pokemon, millions of Pokemon. If we increase the offset once again, there are again a bunch of Pokemon. Fewer than before, but still not zero. And then if we increase this to 12, we now see there are no more Pokemon. So you don't get any results from the API. Now what we're going to do is very similar to what we did before. What we did last time is we said, hey, as long as there is another URL, as long as there is information here, let's make another request. What we're going to do now, though, is we are going to say, hey, as long as there is actual data here, keep running, keep doing this, which means our loop is going to be a little bit different. So we're going to start from here, and we're going to start looping through. Now, first I'm going to show you how to build the URL. If we run this code right now, it is not going to work. It's going to run forever because URL is never going to disappear. But we actually kind of want that. We're going to be doing a crazy thing called while true, and that just means run this loop forever. Now, if you run this loop forever, it's not going to ever stop until your computer turns off or you shut down your server or something like that. So we have to manually escape from this loop. Now, when we escaped from the while loop before, it was actually checking something. It was saying, is there a URL? Is there a URL? Is there a URL? This time, we're going to be running this line called break. And what break says is just take me out of this loop. Take me out of this loop. I want to escape. So if I run this code, it's only going to go once, and that's going to be it. Because as soon as it hits break, it's going to be gone. Now, let's say we're counting like we did before. We're going to start with offset equals 0, and every single time we go into here, we're going to say offset equals offset plus 100. And maybe I'll say if offset is greater than 500, break. So what's going to happen is this loop is going to run forever, increasing offset, increasing offset, increasing offset, increasing offset, until this happens. If offset becomes more than 500, it will break. So if we run it, I guess I should probably fix up our URL. The URL is going to be offset equals offset and limit equals, we'll have a limit variable, because why not? Maybe we want to change it at some point. Okay, so we can see that offset is slowly increasing and slowly increasing and slowly increasing. Once it gets above 500, then it kicks out. So how are we going to turn this into something that we're going to work with for our Pokemon? Well, instead of saying if offset is greater than 500, or even dealing with offset at all, what we're going to be doing is saying, are there still results? Are there still results? For here, yes, there are still results. Get another page. For here, there are not still results, so we don't want to get another page. So in here, I'm going to say, hey, we're going to request this URL. I'll grab the URL, get the data from the URL. If we have, let's say we'll do if len data results is 0. So if there are no results here, just exit. Otherwise, take our Pokemon and extend it with data results. So, are there any Pokemon left? Or did we find any Pokemon? If not, exit the loop. If we did find Pokemon, add them to our list, and then move on to the next offset. And so it'll just keep looping. Request. And we see this one is different from the last one, where the last two stopped at offset 1100, right? Because they're only 1118. For this one, it had to actually go all the way to 1200, because this is the first time where there are no more Pokemon, where no Pokemon end up existing, and that's where it says, okay, we actually don't have any more Pokemon. Let's say that we're done with this. Now, one more way of doing this. The final way, well, let's just first method, this is called going until no more results. So the pros, it's very flexible, and the cons are extra requests, doesn't really listen to the API because we're grabbing URLs that it doesn't necessarily want us to grab. It's maybe it's a few more lines of code. The final way is waiting until things break. It's similar to what we're doing before. So let's actually go through this code here, and we're just going to adjust it a little bit. This technique is especially good for scraping, but we'll get to it. So what I want to do is, instead of saying, did we find any Pokemon, I want to print out the first Pokemon. Because, maybe I want to debug by printing out the first Pokemon. Because, for example, before we, a few times ago, for maybe the first example, second example, we requested that first page twice in offset of 0. So it might make sense to kind of check what Pokemon we're getting on every page. So I'm going to run this, and it's to say, okay, Bulbasaur is the first one, Electro is the second one. Okay, so we are successfully grabbing a new page each time. We're not accidentally getting, this first URL twice or anything like that. It's going, everything's working great. But then, when it gets to offset 1200, right, where there are no more Pokemon at this URL, right, no more Pokemon. When we try to grab results 0, it says, no, you can't do that. Can't do that. There is not a first Pokemon for you to grab. The way that we fixed this before is we said, hey, are there no more results? If so, break. We're going to do something slightly different here. What we're going to do is we're just going to look for an error. And if there is an error, then we are going to escape from our loop. In Python, I can say, try to do this If it doesn't work, we found an error. And try will run this code. You can do like a bunch of lines of code in here. And if there's an error, then it is going to run this thing down here. What we want to do, try to print the first one out. If there is no first one to print out, we're going to break, exiting the loop, which means we don't actually need this here. We could also do Pokemon extend in here. It's, you can organize this however you want. But the idea here is, instead of manually checking to say, hey, do we have Pokemon that we can add? We're just waiting until something goes wrong, till it can't find any Pokemon. And then it's going to say, oh, I'm going to exit the loop. Finds Pokemon, finds Pokemon, requests this page, encounters an error, exits the loop. Method, waiting until you hit an error with your processing. Oh, I will note that we can't put Pokemon extend in here because if we do Pokemon.extend data results and results is an empty list, it's still going to work because you can extend, we can add on an empty list onto this list. It just won't do anything. So we have to make sure that we're getting the first element, the second element, printing out something from the results that will no longer be there when we have run out of results. So waiting until you hit an error. So pros, super easy and flexible. This is really good for scraping if you're trying to grab things that happen, like headlines on pages or something like that. Good technique for scraping multiple pages. The cons are, what if there's some other error that isn't you've run out of data. So let's say we were printing out, let's say the name of the Pokemon or something like that, or the name in English, even though it doesn't exist here. Maybe the Pokemon exists, the Pokemon has a name, but it doesn't have an English name, it only has a Japanese name. That would have an error, and then it would pop down here and it would exit the loop, when in reality, the error isn't there is no first Pokemon. The error is that first Pokemon has no English name. Cons, it also looks more complicated. Honestly, probably the one that we did where we just looked at the next URL is probably the easiest one. I'm going to clear all of my code so I can scroll through this easily. This is the first one that we did right here, where we knew the number of pages we had to go through. We had to go through 12 different pages. We just updated our offset. We updated our limit, built a new URL, grabbed the information from there. The second one we did was we listened to the API. We said, hey, what's your next URL? We just kept grabbing that next URL, and as long as that next URL existed, we were able to keep running through our loop here. The other one was we said, hey, if we request something from offset 1200, it then gives us no more results, right? Results is an empty list. So we just said, hey, is results an empty list? If so, we're going to exit from this loop. Otherwise, this loop would go on forever. If you write this code wrong, another con is if you write this code incorrectly, it will just loop forever, and you'll have to Control-C in order to exit out of there. And then the final one we did was similar to this one, where we looked to see, did we find any Pokemon? But what we did was we said, let's try to print out the first Pokemon, and if there is no first Pokemon, we're going to get an error. We'll just swallow that error up, and then we'll pop out here and exit the loop. So things to pay attention to is we updated the URL. We used while loops in general. And yeah, there are just 101 different ways to do it. Probably depending on the API, one or another will end up being more convenient. The end.